and welcome. I'm Elizabeth Kugler. I am the director of Zeeks Out for Geeks, a biomedical image analyst and a science artist. And today I want to talk with you about why biomedical image analysis is so important in the life sciences and medicine. So obviously we know that today's era is completely data-driven, and it is increasingly crucial that we really know how to analyze these data and how to interpret them. And this is especially the case in life sciences and medicine. And so biomedical image analysis has developed as a very important field that allows us to really extract quantitative data from medical and biomedical images. This can include fluorescence microscopy, MRI, or for example, CT data. It can also be very simple, for example, 2D data from histology. And so we need really specialists who are able to quantify these data and translate these images into knowledge. And this is what we call biomedical image analysis. So to actually being able to extract features and information from our images, we need to employ various different techniques, such as image understanding, segmentation, registration, and feature extraction. But all of this really needs a very unique set of information and knowledge. And so this is where we as biomedical image analysts come in. A lot of us are actually trained biologists who kind of then switched over to data analysis, but many are also data analysts who then kind of fell more into the biology side of things. And I would say that biomedical image analysis is a truly interdisciplinary field. And you really see this if you look at, for example, different conferences where actually the conference program is really littered with biology as well as data science and hardcore software engineering to really hardcore biology. So it's a really interdisciplinary and really interactive field. And the most important thing is really that the community is really, really nice and everyone is really helpful and welcoming. So if you do have any questions, reach out to any seasoned biomedical image analyst and they will be more than happy to help you or answer any of your questions. So obviously biomedical image analysis is a huge field and there's many different subfields, and today I can't be talking about all of them, but I just want to kind of pick out some of the challenges that we're currently facing. For example, one huge challenge in the field at the moment is intermodal registration and data analysis. That means, for example, we are at the moment really keen to integrating data from different microscopes or different techniques, such as, for example, a EM image overlaid with a fluorescence microscopy image and correlate these data. Because we're having different techniques and integrating data from different kind of points of information is really valuable to add more information that we could gain from just imaging one or analyzing one particular type of data. So this is a huge field. Another thing is obviously AI, and everyone is kind of really keen on doing AI at the moment, but I think for really kind of quantitative and in-depth application in day-to-day approaches, it's not there yet. AI, I think, will take a little bit more time to really be rolled out into labs worldwide because it is still a very kind of cutting edge technique and just not ready yet to be applied in all the different techniques and all different labs. But again, it is a very, very fast changing field. I think another thing is obviously also that in biomedical image analysis, you need to have a lot of prior knowledge to know what you're doing and how to apply kind of different approaches to your data. And so biomedical image analysis will be changing a lot with obviously now this new generation of scientists who actually are trained in biomedical image analysis, who are trained very, very specifically on their data. We also have huge computational challenges. One very big and obvious thing is that, for example, in light sheet microscopy, we have a huge amount of data. And so being able to efficiently and effectively analyze these data in a fast pace is at the moment not really the case, let's say it like that. And so I think one really exciting thing is that as we gather more computational capabilities, we will be able to analyze big data faster and more effective. But also it obviously means that, for example, data sharing will be way, way quicker because, believe it or not, there's still a lot of times where we just send literally hard drives with terabytes of data across the world, like 10 years ago. So I think this is also a huge thing. Obviously, data storage, archiving, and knowing what to do with data is a huge thing that will change. And also another thing that we see a lot is obviously that we start to acknowledge that metadata are really, really important. And so there's this huge drive to actually not only find new data types, such as, for example, HDF5 or MER or yada yada, but actually being able to really spend some time on what can we do with the metadata and how important metadata are, because we start to realize that actually acquiring data is very expensive. And so we want to make sure that if we store the data on hard drives and keep them for years, that we actually keep the information of like who acquired them, what is the sample, what is the staining, and why is this important to actually keep this data. As I mentioned, there are many different routes how you can actually become a biomedical image analyst, and I myself, by training a biologist who kind of slipped into biomedical image analysis, by accident, coincidence, I don't know. But obviously, you can early on, for example, in your bachelor's already pursue, for example, biomedical imaging or bioinformatics if you know you're interested into that. You can also, like I said, start with essential skills like programming, understanding microscopy a little bit more, and kind of, start to think about statistical approaches as well as machine learning. One important thing for me personally was always to gain experience. So I tried to do internships or kind of go to other labs, as well as work with other people who I knew would be working with interesting data or biomedical image analysis. I was able to build a portfolio by having these internships, but you can also build a portfolio nowadays with, for example, open data challenges. You can go on Kaggle where there are data up there, and you can look for open source data and actually just write some code on them and really start to understand how they work. I think another thing that I never kind of had when I was going into this direction, because it's quite a few years ago, is actually the very fact that nowadays there is a lot of open source courses, but also, for example, on YouTube, there's a vast kind of amount of data that you can use, a vast amount of videos that you can use to actually learn for free, which is great. And obviously, again, there's a lot of online courses where you can actually get certificates if this is what you're really after. But if you want to learn a little bit more about the different resources, make sure to sign up to our Zeeks newsletter, as well as there is a link in the description where you can get access to some more free resources that we have at Zeeks. So it would be great if you just have a click down there and have a look at the resources and let me know what you think in the comments. So thank you.